In this lesson, we're going to be finding the inverse of this matrix using Cayley Hamilton theorem. So matrix A is giving us the row 1 is made up of 2 and 1, and then row 2 is 0 and 3. So to start with, we're going to find the characteristics equation of this matrix A, and then the formula for it is matrix A minus lambda times identity matrix equals to 0. And this is the determinant of this, right? Determinant of matrix A minus lambda times identity matrix equals to 0. So let's compute this. So matrix A is giving us 2, 1, 0, and 3. Then minus lambda times identity matrix, then equals to 0. Let's not forget the determinant. So this one now is going to be equals to, then we have 2, 1, 0, and 3. Then minus lambda times 1 is lambda, lambda times 0 is 0, lambda times 0 is 0, and then lambda times 1 is lambda. Then all of this will be equals to 0. Let's close this determinant sign. Alright, so we're going to have now 2 minus lambda, just 2 minus lambda, then 1 minus 0 is 1, 0 minus 0 is 0, then 3 minus lambda will just be 3 minus lambda. Now let's find the determinant of this matrix. So we're going to have determinant of this matrix 2 minus lambda times 3 minus lambda. We have 2 minus lambda times 3 minus lambda, then minus 1 times 0 is 0, then equals to this 0 here now. So 2 times 3 is 6, 2 times negative lambda is minus 2 lambda, minus lambda times 3 is minus 3 lambda, then minus lambda times minus lambda is plus lambda square. Now minus 0, nothing, then this is equals to 0. Now we have 6 minus 2 lambda minus 3 lambda is minus 5 lambda, then plus lambda square equals to 0. Now rearranging this, we are going to have that our characteristics equation is equals to lambda square minus 5 lambda plus 6 is equals to 0. And this is the characteristics equation of this matrix A. Applying Cayley Hamilton's theorem, we're going to replace this lambda with this matrix A. So we're just going to write A square minus 5 times A plus 6. Now you can add or subtract matrix with a scalar. So I'm going to multiply this is by identity matrix to make it a matrix. Then this is going to be equals to 0. Now this is the Cayley Hamilton theorem. Now let's factor out A from these two terms. If you factor out A from this A square, we are going to be left with A, then minus 5A divided by A is 5, but this is a scalar, so we're going to multiply it by identity matrix. Alright, and have plus 6I equals to 0. So we have A into A minus 5I, then equals to, let's take this 6I to the right hand side, it's going to be minus 6 times identity matrix. So let's multiply both sides by A inverse, so that this and this will cancel. We will be left with A minus 5I at the left hand side, and then this will be equal to minus 6I times A inverse. Now we're going to treat this negative 6 as a constant, so we're going to throw out this inverse matrix because it did not change anything. So let's divide both sides by negative 6. Alright, so that this and this will cancel. We have A inverse is equals to minus 1 over 6 multiplied by A minus 5I, or A inverse is equals to 1 over 6 into 5I minus A. right? Then we're going to work with this. So this is the formula for our A inverse. So what we're going to do next is we're going to simplify this 5 times identity matrix and then minus the main matrix divided by 6. So that is what we're going to do next. So we now have that inverse of matrix A is equals to 1 over 6, then multiply by, now 5 times identity matrix is going to be 5, 0, 0, and 5, then minus this matrix A, which is 2, 0, 1, and 3. So we have that A inverse is equals to 1 over 6, then multiply by 5 minus 2 is equals to 3, 0 minus 1 is equals to negative 1, 0 minus 0 is equals to 0, 5 minus 3 is equals to 2. We now have that A inverse is equals to, now 1 over 6 times 3 is the same thing as 3 over 6, which is equals to 1 over 2. So what you have here is 1 over 2. Now 1 over 6 times 0 is equals to 0. 1 over 6 times negative 1 is equals to negative 1 over 6. 1 over 6 times 2 is also equals to 2 over 6, which is equals to 1 over 3. So here is 1 over 3. So, and then this is the inverse of this matrix A. So as you can see, we found the inverse of this matrix A without using row reduction method or determinant method. So thank you for watching. Please feel free to subscribe to my YouTube channel, like my videos, share with your friends, and don't forget to drop a comment. See you in my next video.